Okay, so we are looking at relations and functions, parallel and perpendicular lines. So it's lesson 9 in your notes package, page 37. You may notice that we're skipping a lesson just for essential learning outcomes. So let's talk a bit. Now we know what parallel and perpendicular lines. Parallel lines are two lines that have the same slopes. So we're looking at two lines. They would have the same slopes. They would be parallel lines like train tracks, that sort of thing. So let's look. Parallel lines are lines that are equal distant from one another, so they will never ever cross. For example, different lines of a railroad track or opposite ends of a rectangle or a square. And two lines are considered parallel if they have the same slope. So we're going to graph these two lines here and see what happens. Now, thinking about these in terms of our y equals mx plus b, they're both in that form and they both have the slope of 2. So let's take a look. We graph the first one, y equals 2x plus 1. So if x equals 0, then y would equal 1. If x equals 1, 2 times 1 is 1. 2 times 1 is 2, plus 1 is 3. If x is equal to 2, 2 times 2 is 4, plus 1 is 5. So our first line goes like this. Again, sorry, I don't have a ruler. It's because it affects the screen. But it's generally, if you plot those points and if you use a ruler, which I recommend, you'll get a nice straight line. Second one, if x is 0, 2 times 0 is 0, minus 3. That's our first point. If x is equal to 1, 2 times 1 is 2, minus 3 is negative 1. 2 will give us a positive 1. 3 will give us a 3. So we have these two lines and they are parallel. They will never cross. If we note, it says, what do we notice? Well, they're parallel with each other. Their slopes are the same, so they will never cross, never touch. So they have the same slope, but they do have different y-intercepts. So that's the plus 1 and the negative 3. Those are the y-intercepts, and those are different according to that line. Identifying parallel lines. So what this means is that we can identify parallel lines if we can figure out the slope of two lines and put them in the y equals mx plus b form, or find out their slope. And if they both have the same slope but different y-intercepts, then they are parallel. Okay, so let's take a look. How do we do that? Well, let's see. We have line GH passes through G and H. G is negative 4, comma 2. So negative 4, comma 2. And H is 2, comma negative 1. And so that's line GH. Okay. And then we have line JK, which passes through J and K. And J is negative 1, 7. 1, 2. Right there. And K is 7, comma 3. Okay. Sorry about my really scoochy lines. That's why we have to check these. We're going to check those slopes because my lines are not very pretty. 1, 2, 3, 4. Okay. And then we've got line MN. And I'm going to do it in green, but I'm going to do it in a darker green, so hopefully it shows up better. Okay. MN is -4, 5. So right there. And N is 5, 1. So 1, 2, 3, 5. So we have 3 lines. They may or may not be parallel. So what we have to do is we have to find the slopes of all those lines. So let's do the first one. Remember, the slope is equal to y2 minus y1 over x2 minus x1. So using that for G and H, I'm going to have -1 minus 2 over 2 minus -4, right? So that becomes plus a positive. So I get -3 over 6, which is -1/2. And that makes sense. It's a negative slope because it is going down. Let's figure out our slope for, because this was slope for GH. And this is slope for JK. So again, it's y2 minus y1 over x2 minus x1. So looking at those, I'm going to make k my y2. So it'll be 3 minus 7 all over 7 minus a -1. 3 minus 7 is -4. And 7 minus a -1 becomes plus a positive, which is 8, which is -1/2. So right now, that tells me that JK and GH are parallel. So now I just have to test MN. So again, y2 minus y1 is equal to x2 minus x1. So I'll make N my y2, or my second point, and N is my first. So I'm going to have 1 minus 5 over 5 minus a -4. On the top, I get -4. Here I get plus a positive. 5 plus 4 is 9. So, that is a different slope. I can't reduce it to -1/2. So this tells me that, what this tells me is that GH and JK, those lines are parallel, but MN is not, because these have the same slope. This has a different slope. Parallel lines must have the same slope. Okay? All right. So let's now move on to the next page, which talks about perpendicular lines. Perpendicular lines are lines that intersect at right angles to each other. And there we talk about them using this symbol you can see right there. That's for perpendicular lines. Two lines are considered perpendicular if the slopes are negative reciprocals of each other. That is, a line with a slope of A, where A is not equal to 0, is perpendicular to a line with a slope of -1 over A. So it's the negative reciprocal. The reciprocal is when we put it as 1 over, and negative reciprocal is when we make that value negative. So perpendicular slopes, when you multiply them together, they should equal -1. Okay, so let's take a look. Lines AB and CD are perpendicular to each other. Find the slope of line AB and line CD. What do you notice? So let's find the two slopes. We can use 2 points on either line, or we can just do rise over run. So the slope of AB, so if we look here, we have AB. It goes from 0, -3 to this point here. So we can say it goes from 0, -3, and the second point is 4, 2. So we'll calculate that slope. So again, it's y2 minus y1 over x2 minus x1, which is 2 minus a minus 3 over 4 minus 0. So we get for our value, did I do that wrong? 0, -3, and 4, 2. Oh wait, I should use this point here. Let's use that point there, because this one might not be exactly right. So let's use that point, which is 1, -2. So I'm going to just revamp this. Sorry about that, guys. So y2 is 2 minus -2, and x is 4 minus 1. So I get, this becomes plus a positive 4 over 3. Sorry about all that. For m of CD, let's use the points. It does cross through that same point there, that 4, 2. And we'll use the point, we can use C or D. Actually, we probably should use C or D. So D is 8, -1. Right? Okay. So y2 minus y1 over x2 minus x1 is equal to, well, on top I'm going to have -1 minus 2, and on the bottom I'm going to have 8 minus 4. So I'm going to get -3 over 4. Now, what do we notice? Well, if you notice, if I take both of these slopes, if I take 4 over 3 and I times it by -3 over 4, so I'm taking both of the slopes. So this is slope AB times slope CD. What I get is -12 over 12, which is equal to -1. So I get the negative reciprocal, or I get this, so they are negative reciprocals of each other. Okay, so they are negative reciprocals. Okay, so using that, let's play around with some slopes here. Determine the slope of a line segment that is perpendicular to the given slope. So if I have a 4, that's like having 4 over 1. So I want the negative reciprocal, so that'll be -1 over 4. If I have -2/3, I'm going to switch 3 over 2, and it's negative to begin with, so I make it positive. Okay, so I'm basically changing the sign and flipping it. I have 4 over 5, so that will be -5 over 4. And you can put that negative sign in the middle or on the top. I don't like negative signs on the bottom, so I tend to shift them to the top, but there's only one. If I have -5 as my slope, it's like -5 over 1, so that would be like 1 over 5, and it would be positive. Okay? All right, identifying perpendicular lines. So let's take a look here. The line ST passes through S, which is -2, 7, and T, 2, -5. So let's plot those. -2, 7, 1, 2, right there, and 2, -5, right there. So that's S and that's T. So this is our line ST. And apologies for the not straightness. Okay, the line UV passes through U and V. So U is -2, 3. And V is 7, 6. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6. Okay, so U and V. So we join those up. Now what we want to know is, are these two perpendicular? So what we have to do is we have to calculate their slope. If I calculate their slope and they are negative reciprocals of each other, that would mean that they are perpendicular. So let's do the slope of ST. It's y2 minus y1 over x2 minus x1, which is equal to -5 minus 7 over 2 minus a -2. That becomes plus a positive. So I get for my solution -12 over 4 or -3. And that makes sense. It's a negative slope. It's going down. We would assume that UV is going to have a positive slope because it's going up. But let's do our math and figure out what our slope is. So y2 minus y1 is over x2 minus x1. So U is, 6 minus 3 for our y's, and 7 minus a -2 for our x's. This becomes, whoops, sorry about that. Let's scroll to the correct page. My apologies. There we go. All right, we're back. Sorry. So here 6 minus 3 is 3 all over. This becomes plus a positive, so over 9. 3 over 9 can reduce to 1/3. Now, -3 over 1 times 1 over 3 is equal to -3 over 3 or -1. So, yes, they are perpendicular. The slopes are negative reciprocals. Okay? Alrighty, so that's how you tell if they're perpendicular lines. You find the slope of both lines and then see if they work to be negative reciprocals. And sometimes they can seem like they might be, but doing that multiplication will really kind of confirm for you. Okay. Let's do a little more examples here. Identifying a line perpendicular to a given line. So, determine the slope of a line that is perpendicular to the line E that has the points E, 2, 3, and F, 4, -1. So let's find the slope of EF, and then we can find the slope of the perpendicular line. So y2 minus y1 over x2 minus x1 equals -1 minus 3 over -4 minus 2, which would get me on the top -4, on the bottom would get me -6. Those two negatives will cancel out, and I can reduce this to 2 over 3. So the slope of a line that's perpendicular, remember we talked that was the sign for perpendicular, would be that negative reciprocal of this. So it would be -3 over 2. Okay, so that would be the answer to the question being asked. Now, determine the coordinates of G so that the line EG is perpendicular to the line EF. Well, that means that E is on that line. So E, as we can see, is 2, 3. And we know F is -4, -1. So this is EF. So we draw our line through there. So we want a line that goes through that point, E, but has the slope negative 3 over 2. So the slope is negative 3 over 2, and it goes through the point E, which is 2 comma 3. So we start with that as our point, and we're going to figure out our slope. Now, it's rise over run, okay? If it is negative for our rise, that means we're going down. So 1, 2, 3, and over 2. Okay, 1, 2, 3 over 2. So this would be, these would be equivalent coordinates. So we have 4 comma 0 and 6 comma negative 3, and you can keep doing that. And we can just connect these 3 points. And again, use a ruler. I'm freehanding it, and that's probably not the best. I kind of want to erase it and do it over because it's not good. So I'm going to do that. Hopefully I can do it better. Oh, so much better. Okay. And that would be but it wanted you to determine the coordinates of G. So you can use either one of these. So if we say this is point G, that's fine. But you could also use the other one. It just has to be an appropriate point that would work. So we just counted the slope to figure that out. Next question. Determine the slope of a line that is perpendicular to the line through G, negative 2, 3, and H, 1, negative 2. So this is very similar to the last question. So if you want to give it a try, I'm going to recommend you do that. And then press pause. When you're done, come back. So press pause. And we're back. So we have G and H. So we're going to first figure out our slope. So y2 minus y1 equals over x2 minus x1. So we have negative 2 minus 3 and 1 minus a negative 2. This becomes plus a positive. So I get negative 5 over 3. So perpendicular slope is going to be 3 over 5, and it'll be positive. So we want the coordinates of J so that GJ is perpendicular to the line GH. So let's sketch our GH first. So negative 2, 3 is G, and H is 1, negative 2. Okay, so this is H. So we'll sketch that line. Okay, and now we need a point J. So we can use our rise over run and just use that to count. The slope is 3 over 5. So counting from point G, we're going to go up 3 because that's our rise, right? Rise over run. Up 3, 1, 2, 3, and over 5. 1, 2, 1, 2, right there. 1, 2, 3, 4, 5. So we can make that J. So we'll say that that is 3, comma 6, right? And we connect those. Now, your point can be anywhere on that line. If you wanted to go further, you could. It could be 8, comma 9. You could have gone down. As long as it's on that line, that you use that rise over run to find that solution. Okay? Alrighty. One more page here, guys. So let's take a look. As soon as I scroll up. Okay. Writing an equation of a line that is parallel or perpendicular to a given line. So we're mostly using our y equals mx plus b form of a line here. And we're going to use the information there and figure out the equation for those lines, okay? And they just have to fit the criteria. So if it is parallel to the line y is equal to 2/3 x minus 5, parallel means the same slope. So our slope for our new line is going to be 2/3, right? And it passes through the point r comma negative 1. So we know for our equation y equals 2/3 x plus b. So we're going to take that point 1 comma negative 1. We're going to substitute that in for our x and our y. So our y is negative 1 times 2/3 x. X is 1 plus b. Then we're going to rearrange and solve for b. When I rearrange and solve, I'm going to get 2/3 times 1 will be 2/3. So I'm going to move that over to the other side, and that will equal b. So b will equal, negative 5/3. And that's just using some fraction math, because negative 1 is the same as negative 3/3 minus 2/3 equals negative 5/3. Okay? So from that, my equation will be y is equal to 2/3 x minus 5/3. Okay, and the next one I'm going to try and do the math a little cleaner, just so it fits all in a nice box. The next one wants it to be perpendicular. So perpendicular means that it's going to have the negative reciprocal for slope. So if it's 2/3, it's going to be m is equal to negative 3/2. Okay, so that means y is equal to negative 3/2 x plus b. Again, we're using the point 1 comma negative 1, and we're going to substitute that in for x and y. So negative 1 is equal to negative 3/2 times 1 plus b. So I get negative 1 equals negative 3/2 plus b. I move that over to the other side. Negative 1 plus 3/2 equals b. So b would be equal to, well, negative 1 plus 3/2, it's going to equal 1/2. Right? And again, that's using your fraction math. 1 is the same as it would be negative 2/2. So from that, our equation is y is equal to negative 3/2 x plus 1/2. And that would be our equation. Okay? So the first thing you do, figure out the slope based on the information given, based on whether they want a parallel slope or a perpendicular slope. Then you take the point given and substitute it in to solve for the y-intercept. Okay? Alrighty. Write an equation for the line that passes through s2 negative 3 and is, now this is same as the last question, so this is a good point for you guys to try this on your own. So pause it, try it on your own, and then come back when you're finished. All right, so let's do the first one. It's parallel to the line y is equal to 3x plus 5. So that means it's going to be y is equal to 3x plus b. We know that it goes through 2 comma negative 3 because that's the point given. And we know the slope is 3 because it's parallel. So let's substitute in. So negative 3 is equal to 3 times 2 plus b. All I'm doing is substituting in this point into the equation. So negative 3 equals 6 plus b. I move the 6 over. Negative 3 minus 6 equals b. So b equals negative 9. So if I'm writing my equation, it's y is equal to 3x minus 9. And we'll put that in a nice pretty box. Okay, let's do the next one. This one is perpendicular to this. So that means that my slope is going to be negative 1/3. Okay, so y is equal to negative 1/3x plus b. And I'm putting in that same point, 2 comma negative 3. I'm going to substitute them in. Y is negative 3. M is negative 1/3. X is 2 plus b. Let's solve this. So I'm going to get negative 2/3 plus b. Now I want to move that over. So it'll be negative 3 plus 2/3 equals b. Think about your fraction math. Negative 3 plus 2/3. Well, that's the same as having negative 9/3 plus 2/3 equals b. So b is going to be negative 7 over 3 equals b. So from that, I have my equation. Y is equal to negative 1/3 x minus 7/3. If you know you have trouble with fractions, you might want to take some time to review those rules because you'll be doing a lot of adding and subtracting and multiplying of fractions. So please take that time to review those. You should have those skills by now, but sometimes we don't use them a lot, so it's good to go and practice. All right, one last question. This one's a little more complicated. We have a triangle, and it says the triangle has its vertices at the following points. So I'm going to just sketch this. A is negative 2, 3, so it's probably around there. So that's A. B is 8, negative 2, so somewhere around there. And C is 4, 6. Okay, so it says sketch the triangle on coordinate axis. If you have real graph paper, that's even better. And they want us to prove that ABC is a right triangle. So we want to see, is this a right triangle? So what that means is that if this is going to be a right triangle, that means that AC, slope AC must be perpendicular to the slope of BC, okay? So that's what we have to prove. So we've got to find our slope of AC and find our slope of BC and figure out if they are perpendicular, okay? The slopes must be perpendicular. It's a long word. Okay, so let's do that. We know how to do that, right? So let's find the slope of AC. So y2 minus y1 over x2 minus x1. A and C. So we'll do 6 minus 3, 4 minus negative 2. And to be honest, it doesn't matter which order you put them in. You'll get the same slope. On the bottom, then minus a negative becomes plus a positive. So we get 3 over 6, which is equal to 1/2. Okay. Alrighty. And then we're going to do MBC. And let's figure that one out. Y2 minus y1 over x2 minus x1, which is equal to, so we're using B and C. So we're going to go 6 minus a negative 2 all over 4 minus 8, which would give us 6 minus a negative 2 would be plus a positive, so that'd be 8. 4 minus 8 would be negative 4, so this will give us a negative 2, and we can see we do have the negative reciprocal. We should probably also actually check out the slope of AB, because I just made an assumption there that the right angle was ACB or BCA. So just in case, now I can see already that these are perpendicular, but you may not have known that off the bat. So let's just test that just to see what it is, because sometimes you might have to calculate all three. So we're using A and B. So we're going to have negative 2 minus 3 over 8 minus a negative 2, which becomes plus a positive. So I get negative 5 over 10, which is negative 1/2. Well, it is not a negative reciprocal of either because it is the reciprocal of negative 2, but not the negative reciprocal. But these two are, so that means that that is where our right angle is. Okay, so with those triangular questions, or you might get a parallelogram or a square, let's say to prove it's a square, you might have to find more than just two slopes. You might not know which ones, so you have to kind of map it out. I always say draw a picture. That will help you. And then your assignment for this is right here. Thank you. Once you finish your homework, make sure you do your Google Form assessment, which should cover this and the previous lesson. You'll notice that there's also the practice test on page 399, so give that a try. That will give you